Hello, welcome to this video. Today we're going to do this problem. What are we going to do? So, define the series AN as follows. So, we start with A0 is equal to 1, and A1 is equal to 5,782. And then AN is AN minus 1 minus AN minus 2 plus N. So, maybe let's find a couple of values just to get an intuition for maybe how to what to do with the series. So if A is equal to 1, A1 is, well, it says it's 5,782, and because that number is so big and so random, seems like we can almost just ignore the precise number. So I'll call this number A. And from here, I'll evaluate A2, A3, A4 until we've had enough, until we maybe see a pattern. So A2 is equal to A1 minus A0 plus 2. So it's A minus 1 plus 2. So it's A plus 1. Yes. And A3 now is A2 minus A1, which is exactly 1. Plus 3, which makes it 4. Next, A4 is equal to 4 minus A minus 1. So that's 3 minus A plus 4. And so that's 7 minus A. Then A5. A5 is going to be what? It's A4 minus A3, so that's 3 minus A, plus 5, that's 8 minus A. And then A6 is equal to A5 minus A4, which is exactly 1, plus 6, which is 7. And if we look and we see, well, we have some A here, this is only 7 minus A, 8 minus A. But if we look at just when the multiples of 3, A0 is 1, A3 is 4, A6 is 7, and they're completely independent of A. So it seems like these are really that for multiples of 3, so for multiples of 3, so A3k, it seems like maybe it's just the number plus 1. A6 is 7, A3 is 4, A0 is 1. So this is what we want to prove, because if we prove this, we're done, because 3 is obviously divides into 2022, meaning that we'll have our answer, get our answer easily. So let's maybe play with this. So let's maybe look at AN plus 3, since we, and the really, so look at AN minus 3, AN plus 3, AN will also work, just because we're going to reduce it up until something with just AN, or I'm going to use AN plus 3 just for just a little bit nice to work with. So this is by definition AN plus 2 minus AN minus 1 plus N plus 3. But now I can use this on AN plus 2. So this is going to be AN plus 1 minus AN plus N plus 2. This is AN plus 2. And then we have the rest. So minus AN plus 1 plus N plus 3. And now AN plus 1 cancels out. We get 2N plus 5 minus AN. Now this seems to be peculiar. Maybe we would have had AN plus 3, that would have done it. But notice, if AN is equal to N plus 1, if for some specific N, AN is equal to N plus 1, then AN plus 3 is equal to 2N plus 5 minus N minus 1, that's N plus 4. So if we jump, so if this is true for a specific number N, then we can add 3 to it, and it'll still be 1 plus it. So if an is equal to n plus 1, an plus 3 is n plus 4, which would also mean an plus 6 is n plus 7, and in general, an plus 3k would be exactly n plus 3k plus 1. This is true if there is some specific number n for which an is equal to n plus 1. But notice, let's look at what we're given. A0 is equal to 1. Well, last time I checked, 0 plus 1 is equal to 1. So if A0 is equal to 0 plus 1, but what we just proved, this is formally proved by induction. If you use this induction process, we get a 3k, because the n is now here just 0, equal to 3k plus 1. And indeed we managed to prove what we wanted to prove. And now, since 3 divides into 2022, we can pick k to be 2022 over 3. And we know this is going to be a whole number, so it's fine to do that. And we'll get a 2022 is 2022 plus 1, which is 2023. And that's it. If you want more content like this, please subscribe to my channel. I'll be uploading more interesting problems and things like this in the future. And finally, that's it.